This is the lesson. Okay, thank you. Good afternoon, everyone. I am Akhil. I am a PhD student at Chenhui University, and I'll be talking about the origins of FRB scattering, how we can characterize FRB scattering and other properties via the host galaxy substructure. And I'm working on this project with Professor Adam Teller and the rest of the team. And just to note, this is a project is in its preliminary phase, quite preliminary. That just an introduction. So with the set of we are now able to move from studying whether which challenges are part of the galaxy so more about the environment and spatial distribution models show that most of the information is most analysts paradigms. But growing subset of these advantages is actually better explained by seemingly better explained by the cluster models. And this spatial diversity actually suggests that there are not many channels. So there are two distinct coordinator channels. The coordinated representation is better in the matrix of operators, and the dynamic coordinators, which so the matrix star operators, we have the environment that are characteristics in Balzan, where the operators simply have global clusters that we create. And these models have different expected offsets and have effectively based on the environments. Okay, so why do we need to study these facts? The first and the positive thing is that I can sustainable in the models, and that's a good thing. But the negative thing is that scattering is actually a pain to work with. It introduces a lot of effects and removes FRBs to other line between people observe and advises the observer about population, and also it impacts the population studies if it's not what I'm known for. Therefore, we need to understand scattering and find ways to work around them. And for all this scattering, so there are static is caused by the environment that's how it comes from. There are two things that first is the lower host environment and the second is the lower coordinated environment. And based on that, whether it comes from the risk of galaxies or if it's coming to the lower clusters, we can say that another might have higher level spectrum. And since we know that the global force properties influence scattering, we therefore can use full formalized offset and local environment application to hide the prevent scattering. So before I go to the results, I want to explain how we work the data set. So we are using the same data set on the bottom and the picture, and which has about 83 FRBs from the design of 2024, 3 non-parameter FRBs from the lower resolution. And we also take data from high resolution pictures, and also the QRT. And then, as far as paper, these FRBs actually undergo rigorous filtration so that we only have ones that are not washed with spectroscopic redshift, good localization, and deep field imaging, which gives us about 34 FRBs, which can be seen here in this set of plot. And you see quite a information for FRBs also, right? And then these FRBs are modeled using Gaslight to find stories of the surface pattern from the places. So as to find the post-moment offset and the global cluster distribution. And finally, after this, we take the FRBs to other places, so that we only have FRBs that have a good enough confidence to a specific footprint. So we find the post based information criteria values for the models, which are basically the optical or medium high level value. And we can do the content matrix, and if the content is high enough, only then we choose the FRB, which gives us 21 remaining FRBs of the total of second. So already we can see that now the is quite small. And also one caveat to note that even though the government package might be high, most FRBs usually don't prefer model very strongly. Usually have difference on the interface and whole this or the custom models. And even though the FRB might prefer a model, it doesn't necessarily mean it's the correct one. It might be the right color, that might be more like. With that, I just give two examples. Here's an example of the FRB 2020 or 120E, and this one has a clear difference to the regulation model because of exposing to sky. And another example is the FRB 21.470, which even though has a difference residual model, it's not a very high difference. And it could be any other model. So this is something we actually get to know is some kind of increase. Coming to some of the results, here I show the most common offset vector for glass. And if you look at the right hand side, this FRB this model, we see that most of them have a performance offset close to 1, which is good. That's good. But when we come to the industrial models, we see that there are a lot of variations. And although ideally the FRB should have a larger performance offset, there are two FRBs here which are outliers. I talk about FRB 21 level 25, which seems to have a much smaller performance. And here you can see that the FRB is coming from low mass spiral galaxy, and that is clearly extended. And because of its mass, it actually has very compact global cluster distribution. And since the FRB is coming from close to the center, the model actually prefers the global cluster over the profile of this model. Even though it's most likely coming from the model, so this FRB will clearly follow in the watermetal paper, and this is the kind of FRB that actually devices of them should not be used. So another curious thing is that even though we are quite sure that this FRB comes from the disk structure. When we see this pattern ranks, which I think we have the lowest pattern rank, which is something for placing, which is the least, because we expect FRBs coming from this to have a higher starting time. But yeah, so that means it's something that should be studied further, and most likely be eliminated from studying population students who has to not higher effects. So given that, I show a plot that compares the scattering time versus the performance loss rate. And logically, if you think about it, the scattering time should reduce with increasing loss rate as we go farther from the center of the host galaxy, the loss rate. But at least there will be no correlation between the but if you see this plot, we can see roughly increasing beginning, which is again quite surprising. And I would first say that the sample set is not large enough to have any statistically significant result here, so no conclusions should be made. But it is still quite interesting to see this, and I think this should definitely be followed up very large and where the so I just said that I can interest in that's because linking pattern and data to specific stuff, I think environment still remains highly difficult, and just getting time scales and not enough to really aspect about one of these. And the bottlenecks we face for our work are primarily the localization. Even though we have sub-Araujo, it still covers multiple local environments, and it's not it needs to be much more precise, especially if we are looking at the single model, FRB using model. And again, scattering is a line of sight effect, and so it will dominated by global post contribution rather than local contribution. That's something that would affect our results. And the solution for that, of course, we can large sample with linear population. And being at this conference, I think that this is one happens rather than later, so that's a very good thing. And secondly, you need to have a very strong footprints, better problems. And in that regard, I think we have successfully shown that we should have shown that by improving the estimacy of the underlying graphics backdrop, you can actually use the polarization of FRBs, and this is a work that I have worked on, and it is shown in the posters there, and there. But basically shows that by improving the estimate of the backdrop, we can improve presentations to what are the kind of modes, which is really good analysis. So with that, I come to the conclusion. And just as a future work, I know that I'm going to also to extend the analysis of that and also when we trying to involve FRBs from other certificates, time we say fast. And as I said, we need more parameters to have a more comprehensive evidence, such as post contamination as well as reproducibility. So that's something that we're working on. Thank you.
Hi, so this is Jaini. So, this is a video studio for example, the Balzan business. Do you like anything you attract to see it later the outputs of the galaxy around the body of person model? Does not seem like a easy track to test it. For the 8 FODs that I have, we started with the student. Do you track the data referentially talking about personal analysis when you wouldn't second analysis and the output to put on the bottom?
I think 2 of them do, but the rest, we should. Yeah, as I said, this is really very well. So that is something that is my to-do list. Okay. If you think about survival values for your sample, maybe for ones that are in the plane, the center of the galaxy wasn't in this category, you never in the second. Yeah, that is likely everything. But it's still not high, that's something not to show and really in couple of them. We did consider it, but we think that we. Okay, question. No, okay, you know, we think it's very good. Hey, next speaker is Lorena Nicotera. Okay, you want to talk about propagation and scattering? Thank you. Okay, Lorena.
Thank you. Yeah, sorry. So good afternoon, everyone. I am Lorena, and I'm a PhD student at the Max Planck Institute for Radio Astronomy, working on modeling scintillation in fast radio bars. And first of all, I wanted to thank the organizers for giving me the opportunity to present my work here today. And sorry. All right, so I will start with providing a very brief scintillation overview. Before then, I show that FRBs challenge the classical approach in modeling scintillation that is typical in pulsars, and that we can improve the modeling strategy through comparison between simulations and observations, before I then end with the polarization content. So first of all, in a nutshell, why do we study scintillation? So we have a coherent radio emission that is propagated through the ISN, and when it encounters a scattering stream, then it gets distorted into multiple path propagations, and they can interfere in a constructive or destructive way, creating the typical interference patterns. And we can measure the scintillation patterns through different observables. I will go through them one by one and explain what science we can do using them. So I start from the scintillation bandwidth, that is the typical frequency scale of scintillation. And this we use to identify one or more scattering stream along the line of sight. And it may also reveal contribution from the local environment of the FRB. And what is the motivation of this analysis? So while for pulsars, we study scintillation starting from the usual dynamic spectrum, where we see that the scintillation patterns are distributed across frequencies, but also they repeat over time. And if we take some time chunks of this dynamic spectrum and we derive the frequency spectra, then we can measure the autocorrelation functions, and usually to get the typical frequency scale, then we model the autocorrelation functions with a Lorentzian model. And if we look at the individual ACFs, we see that this modeling may or may not be stable. However, for pulsars, we have many pulses, so we can average over multiple ACFs to get a more reliable fit. And the half-width of maximum is the measure we are looking for. But for FRBs, the picture is more complicated, as they can often come with one single burst and limited bandwidth. And these, of course, include some irregularities in the overall ACF shapes. And we see sometimes they develop these wiggles, so these periodic maxima in the outer frequency lux. And only repeating FRBs allows the averaging capability. So what I'm working on, I work together with Tim Sprenger, a postdoc in our group, and we want to frame reliable scintillation modeling for FRB, and we use simulations to reproduce the observational cases and to be able to control especially the non-uniform spectral structures and their impact on our measurements. And what I will show today is how individual realizations of the simulated ACF actually resemble the observed ones in one of FRBs. And also I will show how the average ACFs over multiple realizations can stabilize the modeling, even in the presence of isolated scintills, and this applies both to simulated and observed data. And overall, we want to come up with a more realistic uncertainty framework. I start with the example of one-off. Here I am comparing ACFs which are simulated with the ones from one-off FRBs. These are ASCAP FRBs. And what I show is that in the case of limited bandwidth or irregular structures, then the ACFs look wiggly in the outer lux, and we can reproduce such effects in simulations, in which we also see how these ACFs deviate from the classical Lorentzian function, which is here overplotted in black. And I am in particular looking at 15 FRBs from the ASCAP ISS sample, where I measured the scintillation bandwidth and compared with the predictions from the updated electron density model. There is a clear outlier in this histogram, FRB number 10, which is this FRB 2022-1106, for which the autocorrelation function is best modeled with a double Lorentzian component, and this gives evidence for two scattering screens. So we have multiple frequency scales, and I am currently following up on this FRB, looking at this location in the H-alpha map, as well as the vicinity of other objects, like this pulsar. So I will look into the scintillation properties of this pulsar as well, to see if I find any similarities. And now I go to the other case, so the case of the repeaters. And here what I show is again a comparison of simulation and observational data. And the simulated data here are multiple realizations of the autocorrelation functions that then merge into an average ACF. And so the average ACF is more stable and closer to the theoretical model. And for the observational data, I am studying the hyperactive repeater 2024-01-14A, for which we have hundreds of bars with the UBB from FSB that Ninisha already presented, so from 1.3 to 6 gigahertz. And in this slide, I show two different bars in band 1 of the UBB with very different spectral features that also result in different ACFs. And here again, by considering 31 bars, I see that the individual ACFs fluctuate quite a lot. However, I can get an average ACF, which is easier to model. So now I go to the second observable, scintillation timescale, that tells us how quickly the intensity decorrelates due to multipath propagation. And using these two information, I can study the geometry of the system source screen observer and also get the distance of the scattering screen. And I am currently analyzing the time scale of the repeating FRB 121102A. That for time reason, I will not present here today, but if you're interested to know more about this study, then I'll be very happy to chat at any point later. And I go to the last part of my talk, the polarization. Again, the case study is 121102A. And here I am presenting the work of Marlon, who is a PhD in our group, and he could not be here today. He is studying the depolarization with frequency using a network of MIPAT S2 band, so around 2.6 gigahertz from February 2026, and also one epoch from FSB in L band, where this FRB is already known to be depolarized. And here what he shows is that the model that best fits the data points is steeper than the one from the literature. And luckily, we also currently have new detections with the UBB of this source. And over these weeks, we are keeping detecting more bars that can, of course, help to better constrain the robustness of this model, as well as they will be used for other studies also in scintillation. So yes, I will now conclude by saying that modeling scintillation in FRBs is very challenging if one single bar is available, and that repeating FRBs actually make our life easier through averaging, while for one-off events, we have to consider systematic uncertainties due to the frequency structures. So these isolated scintillas that create the wiggles in the ACFs, and through simulation, we are trying to have a more controlled framework to study such effects. And I thank you very much.
The model of the so the model that we showing is the better model, which assumes that we have a smooth change in the rotation measured in string. But actually, if you do see simulation, it suggests that you have this turbulent region, and in that case, depolarization is not due to this smooth change in rotation measure, but it's due to the fact that at any given time, you observe different hotspots that are scattered along the screen, each with a slightly different phase and slightly different rotation angle of the electric field. So this leads to quite different expectations than this famous result that you'll see here, for example, today. I was wondering if you looked into that possibility, and for example, try to look for any independence of the polarization level with the resolution of the spectral or temporal data.
So yes, I'm going to mention that this is one of my my group, and I left there the email address. So for any of us, we will be very happy to consider this.
Thank you for the very interesting data set. Now, you may know that regularly DB has been one representation of that object. So if it is multi-path equalization, that is proportional to the gradient of the magnetic field. And since you measure the gradient, then should you correlate the depolarization frequency against the gradient of RM, and that should be a big signal that fight that.
No, because this is work in progress from the only. So this is showing something in this two items.
Okay, wait, of course, you can do it to the sound and compare the speculates two numbers. Because regularly monitors are evident and every week for the last 15 years. So for every experiment you have, it knows the RM rating, and therefore, if you have two measurements, you can compare with prediction.
I think we can discuss a little. Anyone on the question? Yes.
They expected to be able to change the simulation value over the time that my smear would.
So I don't know. That's why I was thinking the part of that. You lose in the line, you respond to whatever the device will be more than what the other is to and of course I have to get rid of that. Must be.
Thank you. It's next one, Ziwei Wu. Discuss about this situation in my past.
Okay, thanks. First, first I have to say my presentation overlaps with the previous one. Yeah, but I don't have time to make any changes. So, yeah, I am Ziwei, and today I would like to briefly introduce what I have done during the past few years. FRB interstate scintillation with fast. By the way, I have changed the title from scintillation to interstellar scintillation. So this is because scintillation can be also caused by atmosphere or solar wind. So when I say scintillation in this talk, what I meant is interstellar scintillation. So although FRBs have been studied for many years, their origins are still not fully understood. However, we do know that at least some FRBs could be related to the binary system because we see strong evidence, for example, the periodic activity. And we also can see this kind of sudden rotation-dimensional variations. Of course, there are also other possibilities. For example, some FRBs may be located in a supernova remnant because some evidence shows that the FRB may be associated with strong magnetic field and near its source. So the key question is that how can we test those FRB evolutionary scenarios from observations? Luckily, we have interstellar scintillation. Studies of pulsar scintillation has a long history. If a pulsar is in a binary system and the analyzed median close to the source itself, then we should be able to see this kind of on the left side. We should be able to see this kind of periodic variations in scintillation time scale. Or scintillation velocities. This is because the scintillation velocity is just a combination of Earth's velocity, inelastic interstellar medium velocity, and the pulsar turns. If a pulsar has a binary motion, then we should see this kind of periodic variations in scintillation parameters as well. And yeah, similarly, if a nearby supernova remnant dominated the scattering, interstellar scintillation may provide a promising method to probe the local the nearby environment of FRBs. This is the main motivation for studying FRB interstellar scintillation with fast. Here I show an example of the dynamic spectrum. Normally we see two types of frequency structures. The broader one is about maybe 100, the read one maybe about 100 or 200 megahertz, which is possibly caused by some kind of propagation effect or emission mechanism. We are not sure about that. This is still uncertain. The narrow band, we are so sure about that because we think this is caused by the interstellar scintillation. Why are we so sure about that? Let's take a picture at those figures. So this is the traditional dynamic spectrum. So basically what we did is that for each burst, we get its frequency spectrum. So if we put all the frequency spectrum together, we can see this kind of frequency, this kind of dynamic spectrum. If we take a closer look, we can easily notice that those enhanced, those enhanced frequency bands are aligned during a few minutes. This is normally we often see from pulsars. This is the pulsar dynamic spectrum in the middle of this slide. And in addition, the character size bandwidth of the narrow frequency structures is strong frequency dependent. And we also see that the similarity between those frequency spectrum decrease with time. All those features are both consistent with the predictions from interstellar scintillation. So we know this narrow frequency structures is caused by interstellar scintillations. But to do interstellar scintillation is not that easy because we do scintillation by measure the frequency distribution along time and the frequency domains, but there are so many other factors that also can affect the frequency dependence, can also affect the frequency the distribution. So this is why we have to fold the data first. We have to fold the pulsar data first to get stable pulse profiles before we do scintillation studies. But until now, there is no spin period confirmed from FRBs. Of course, if we can see a bright single burst, we can still do scintillation studies. For example, we can do autocorrelation function to get the scintillation bandwidth and the modulation index. But if we want to start, if we are interested in the scintillation time scale and the scintillation arc, then things get very harder. Normally, we have to detect so many bursts within a scintillation time scale. I would say maybe we need 15 bright bursts within maybe 5 minutes. Actually, this is the advantage of fast, right? So in order to test our algorithm or our code or method or whatever, I selected 271 bright single bursts from a pulsar, from a bright pulsar J1509. Then I do cross correlation for every pulse of burst. This gives us a total number of more than 73,000 measurements of coefficients. This is how those coefficients look like. They are all very distributed. If we zoom in this part, we can see there are only a few numbers of outliers. and those outliers won't affect our measurement. We can also get the basic scintillation parameters from this two-dimensional correlation function. We can also see a bunch of scintillation arcs from this secondary spectrum. So until now, we are so confident that our code works well. Then I have to move fast. So then we move our object from pulsars to FRBs. This is the first FRB we test. 0912A. It is very bright and active, so we can easily get the basic scintillation parameters. And we also can see a scintillation arc curve. We can see a scintillation arc from this so-called signal spectrum. Yeah, it's quite amazing because we normally see scintillation arc from nearby pulsars. But what we really interested in is whether there are any short-term variations in scintillation arc curvatures, because they are the strong evidence of orbital motion for FRBs, and yeah, they are also another possible trend in the scintillation velocities. For example, the annual variation caused by Earth motion, and also the linear variation may be caused by the expanding nearby environment of FRBs. This is what we see from our sources. We can see that there is no clear variations. There is no clear variation in scintillation curvatures. Sometimes we can see those kind of we can see scintillation very clearly from simply due to the fact that we can only detect a few number of bright bursts from those observations. If we assume that those dominating, if we assume that the Earth nearby in the stellar median cause the observed scintillation phenomena, we can easily explain the observed scintillation arc curvature very naturally. Okay, then we have another FRB, which is also very bright and active, and we can see clear variation in scintillation arc curvatures. Then this time we can see a clear annual variation in the scintillation velocities. From this kind of evolution pattern, we can easily get the basic scintillation. We can get the basic parameters of the scattering screen. For example, the distance of FRB, which is about 1.4 km, and we can also measure the velocity. No value indicator of the screen may be different, and also measure the velocity of the scattering screen. Yeah, basically, this is what I did during the past few years, but unfortunately, until now, we cannot find any strong evidence showing that some FRB could have orbital motion, but those non-detection also tells us what we should do next. And yeah, this is all I would like to share. Thank you. Okay.
Okay, you serve that second.
Yeah, thank you.
Basically, the big test of so everyone can really well as probably the way okay, really stop.
Hello, everyone. I'm Chenhui Niu from Central China Normal University. because I only have 3 minutes, I'll go through quickly about the new results of the FRB 190520B. So this source has firstly been discovered by FAST, Commensal Radio Astronomy Survey, so-called the CRABS. And when we detected this source, firstly, we found 4 bursts. And using this burst, we constrain this, localize this source into 5 arc minutes. In the following study, we found this source is worthy of notation because we found this source has been associated with PRS, the persistent radio source. This is a second source that's found has been associated with the PRS. And in the DM budget, we found this host contribution can reach to 900 DM units. Also, in the polarization analysis, we found from the GPT results, we found the RM value is extremely high and also show the sign reversal. And because it's very interesting, so that we conduct a long-term monitor of this source using FAST. And we also found a lot of interesting things. Like unlike the other FRB sources, they have the shutdown window, but this source keeps active. In other words, when we use the FAST pointing to it, like take a 1 hour observation, we can also detect a burst. And also interesting thing is we found the activity peak shows a decrease, and also shows the periodic things. This source shows DM decrease dramatically, and we can see the picture here. It can show if you use the original DM to disperse the burst, we can find it will be not very good. And the DM decreasing rate is reaching to 12.4 DM per unit per year. Also, the morphology for this source, they have a lot of like upward and downward frequency drift. Jiaheng Zhang has analyzed the multi-components of this source and found the number of the components follow a parallel. And for the multi-component burst has no difference with the other single burst, like the fluence and the frequency distribution. And also the fraction of the multi-components remain steady over the time, like the 10%. So we're also using FAST and Parse to take the observation. We found 1 burst and show the narrow band frequency emission. And also we're using, because this source has persisted a long-term active, so offer us a very good opportunity to test the connection between the PRS and the FRB. So we found that they have the clear connection between the PRS and FRB. You can see the poster made by Xinming in the back. Okay, that's all, because I only have 33 minutes, so that's all. There's our advertisement here, yeah. Yeah, we get rid of the scintillation of the burst because scintillation cannot contribute that high variation.
Thank you, Dean.
Yep.
Go ahead, please. Speaker, go ahead.
Hi, everyone. I'm Wanjin Lu from NOC, a third year PhD student. And I guess time didn't wait me. So I guess talk before my, that's my slide. Okay. So today I'm gonna present 2 of my works. One is I also appeared on the archive today. You can go through the details yourself. Also, this work is about to distinguish the plasma screen distances between the program plasma screen and the FRB source. So we all know that almost all the FRB repeaters has compact and active non-lethal active regions and around the circumburst environment. So the if the variation of the propagation effects, such as the dipoles, the scattering, and the ion variation, is dominated by the promotion of the FRB source instead of any other variations. The promotion of the source as it moves, the FRB is propagated through the foreground screen at different passes, and the variation could, the joint variation at the same time could roughly help us to estimate the foreground distance from the screen to the source. So based on that, if we assume that the scattering and the B field is dominated by the local environment FRB, we can briefly estimate the plot like this. I don't know if this is working. No, okay. So in the left plot, we assume that the scattering and B field is located in the same region, and the left is not, which is the scattering is far away at 100 PC. So for the left, you can see maybe it's a little bit hard to see, right? The hollowed one, the 2020, 1124A, the diamond just right at the right side of the battery, and also the hollowed one, 2018-09 16B is located right at the battery brightness space, and others located at the SNR. So both these different environment models has could represent at least some of FRBs. Also, if the scattering region is not co-located with the B field, as I said, let's say far away from like 100 PCs, you can see the B field region could also be interpreted by supernova remnant for almost all the sources. And that's basically the main work. And we just present this brand new method to combine all these multiple propagation effects, including dipole, scattering, and ion variation, to estimate or to interpret the astrophysical environment of FRBs. And also there are some quick works. We confirmed the intrinsic flux spectrum FRB recently discovered by Chan, which could be a potential hyperactive one, but not that much burst as we expected in the low sensitivity band. That's also I have only one rolling up banner standing on the ground, not sticking on the wall. So you can contact me and see my poster. Yeah, that's all. Thank you.
Big stage that
Hi, everyone. My name is Michele Woodland. I'm about to be a third-year PhD student at the University of California, Santa Cruz, and I'm presenting on behalf of the CHIME FRB and F4 collaborations on CHIME's first high redshift FRB. There we go. Okay, so this is FRB 2025-0428A. It has a DM total of 1,523 parsecs per cubic centimeter. We were only able to capture the bottom 200 megahertz of the band just due to the CHIME baseband buffer, but within that 200 megahertz, we are able to see some scattering of 1.8 milliseconds at 600 megahertz and 8.6 milliseconds at 400 megahertz. We measured affluence of 32.8 Jansky milliseconds, and the FRB is very slightly polarized. So next, we took a deep image of the field of view, and we identified an FRB host galaxy with an R-band magnitude of 22.8 with deep Gemini imaging. And we ran path on this, and it has a probability that the FRB is associated with the host galaxy of 98%. So we're very confident in this association. And the FRB localization ellipse is shown in red there. It's 0.4 by 0.2 arc seconds. So using all three of the CHIME FRB outriggers. And so then first we try to get a spectrum in the optical with Keck LRIS and then with Gemini. And we were able to identify one feature And based on the lack of other features and the DM of the FRB, we hypothesized that this was the O2 doublet unable to be resolved, which would then correlate to this FRB being at a redshift of 1.24. But you can't confirm a redshift with just one emission line, so then we had to go to the near infrared. And we indeed confirmed this FRB to be at a redshift of 1.243, which is by far the highest redshift FRB that we've confirmed with time itself. You can see very faintly here, this is the H alpha line, which then in the 1D collapse spectrum, this area of the spectrum was the only region where we detected emission significantly above the noise. So even though it's faint, this in combination with the optical spectrum, in combination with the FRB DM, we're pretty confident that this FRB is indeed at a redshift of 1.243. So I'm currently writing a paper on this FRB, and in the paper, I hope to talk about the FRB in the context of high DM FRBs, as well as what the current population models in the field would have predicted the redshift of this FRB to be, and where I think the high DM selection function might be lacking. And I also have a poster presentation at the back of this room right now on this FRB, so I'm happy to take any questions either here or there. Thank you. Sorry, what was this? Oh, is this consistent with noise? No, based on, this is maybe not the best representation of that, but in HiFi, when you like sort of model off the noise, basically the H alpha emission line here is significantly above noise by like a very small signal level, but it's still consistent with noise.
We basically both think it's noise, but we don't because it's loud.
Yeah.
Okay, thank you. We have taken the video presentation. Let's start. First, you are going to walk away, right? Those really yourself.
So I'm 25, based on the same following trigger of 2005 and previous model, projected onto the black plane. You can see visually that accurately this is the partitioning of electrons between spiral lines and the disk. Other major complications include our way of the black extension, the money log, constantly greater than other constant ways, in particular the Fermi models. So our model does stand for that in distance and time accuracy compared to previous models. Here you can see histograms with the model differences between model predictions and observations for distance, DM, and scattering delay. And in temporal, we do better not only in distance and scattering delay and accuracy on average, but also we reduce experiments in these distributions. Now, many of you are primarily interested in what the matching beyond confirmation of the model is for a given line site. And in general, the maximum beyond confirmation timelines are on average about 2009. Here you can see the ratios of the U2V5 and 2001 maximum beyond on the left, and U2V5 and Y-1 in the middle. These are all the maximum left. And then on the far right, you can see the ratios. So, where most FRBs are detected, the largest differences between these models are in the detection of FRB models and towards 5 out of 2 regions. So modeling uncertainties are usually exacerbated in the plane. I think that high altitudes we're actually doing pretty well because our parallax distance sample has really expanded at high altitudes. In the plane, there are still big issues, especially when it comes to the different treatment of the plane distance of our arms between these models. Which really knows that there's this huge discrepancy between the maximum DM that is predicted over latitude 0 degrees between 2016 and then 2001 and 2025 months. So you can download this all now. Using it straight away. This is available in computer implementation and forecast. For computational speed, we recommend using the Furlan version. You can consider this to be a stepping stone towards a completely new model that will be based on an advanced framework that incorporates much more multi-variant information than previous models. So in particular, we're working to incorporate expected stock survey information, as well as the figures of both price and the CNC and using that LB's weight parts. So thank you, and I look forward to interacting with you all via Slack.
It's a movement during this video movement. A lot of those that committee cannot play from. Yes or no? Okay. No, yes or no? Okay. Okay, next we have a video presentation from two Woodland. Hi, everyone. I am at Florida and Araujo. They also look at all our and says about the market. Recent compound results of the problem they have good significantly from the correlation. And this is the same 5% of problem. So they immediately become solved. So we ask the question, can you keep straight around the problem and then when we go by full something of the many our jobs. Part of the many probably become very with our market, the often more distribution than the deviation inside and places them only independently. Then we scatter add scintillation and find so we can compare the real red body and see that I is usually the real red body. But when we use this data in terms of technology recording. Here we have a problem here in the price of the many of our life. Different combinations, the number of marginal, intrinsically and intrinsically elevation by different readings to figure out that the science of those vision values by FRB. And we can overlap this already situation perhaps to strengthen going to market. Start with the track and you can fly by control. The first point is where the basic system side is 0 degrees and the right time side is the lower. A system side increases the behavior also increases and it happens to the right. Similarly, as you get more from days the forward of the turn pattern down. You can repeat this speaker from the marker and stable phase of the population. The other frequencies of the different polarization from 90% of and between the 5 and 6 side of some variables. It said that 7 and polarization 7 and 8% the vision that I can result. Then all fractions down and then other separate tracks. Sometimes the polarization of the system is that elevated polarization and we don't need to go and have second even non-solvent sleeping with statistically significant system birth polarization. Five provides a new level of training or level of significance in the trans and population. And it was the placing number of another video to presentation by Susana.
Hello, and hello, and we all know that most radio also all of it many in the pure and all of solid. I really know we can not go how to go radio so now my job we
we also for managers, repeaters, and we have an here, which is very well and for the rest, we were only able to use it like however, in conservation, we are able to use some in the case of an area of pride of the deep, is the electricity of some of the rays that are alive with the possible outcome of the organization and all the conservation, we were able to the way of living the in particular, his work is failure and this particular work highlights the complementary problems we have we love hearing the video of the year of the vehicle and the previously and with the rate of love if we add the promotion of the so we see that we will be passing on that in this section we have that the is exactly in that where we can get the things in the market. So observing one layer allows to get the evidence, but will not and the very will be covered. On the other hand, on the two sides, on the right, on the right, on the
we have a two may find that we Wanjin and okay, anyone have any questions on this three of them? Yes, please. Oh,
yeah. Yes. Yeah, based on a preliminary Sub-Galactic run from the limited photometry that we have, it seems like supermassive and star. But we want a few more photometers.
The finish.
Yeah.
Oh, I'm happy that the way you canceling situation or take manually it seems all I give you one more minute, right? So I think you have one more minute.
Yes, thank you. Actually, I think propagation effects is filled with questions. I don't know. Maybe I just I need to if I need to reopen my slide. I don't know if because we still have time, right? The first work I introduced, we just consider a scenario that the variation of all these three propagation effects is caused by the promotion of the background FRB source, which could be right, but could be wrong, or could be part of the reason that FRB propagation effects varies. So combine all these observation quantities and for the best circumstances, it should be the simultaneous boundary contained for these three observational quantities. Also, I will show another one for the
Purple one, upper right one, it means R1, but R1 more one.
R1 is located in the SNR region, similarly in the SNR region. In both slot, it doesn't mean that it fits the SNR environment, because the RF variation may not from the proportion of the background source, instead of maybe it's rapid expansion or something, maybe it's extremely young random or something. So our assumption.
Give you 30 seconds. Say what is most important information they should take with them.
So in the future, you have all these monitoring parameters. You can directly test the environment distance, screen distance using our formula, and we believe we provide a brand new method independent of any model prior. That's all.
Any question?
We just want to go back to the list. There is still a signal line that we use there, and this is not the relative level. It assumes the model, the Bell model.
Yeah, it's the fading parameter. Okay.
Happening. And I'm checking the string, and which strictly speaking should be applied to equal. So you have coherent sources with different way, and so we just need to keep that in mind. This may be what's going on, but it's not directly an observable. It's a modeling parameter.
Yeah, it's fading by different models, right? You're definitely right. So yeah, we'll keep it in mind. Thank you.
Do you have some?
If your work basically trying to understand where the RM variation from center of light coming from in the working sources.
Sorry, RM variation what?
Are you looking at the sources? Environment very, very common. And are you trying to explain why that is very?
Maybe this is a little about RM is component by the local environment. Also, the environment variation is not that simple to paper. We just divide into several stages or something to separately estimate the result. Yeah, very difficult.
Okay, next. Michele, do you like to spend 30 seconds?
Sure. I guess on the note of high DM FRBs, one of the things that I talk about, in my poster that I want to think about more, is so right now we're able to observe individual high DM sources, but in the future we're going to have so many of them that we're not going to be able to individually follow up all of them. So it's important that we make sure that we're characterizing the high DM selection function well, which I think maybe we're not doing the best at the current time. Because for example, in Chime FRB catalog 2, we have 169 FRBs above a DM of 1500. So that's a lot of high DM FRBs that in the future we will be able to well localize, but won't be able to follow up. So that's something that I'm thinking about more as well.
Okay. Any comment, please?
My question was the FRB technically very bright. What's the sort of horizon you see that the radiation horizon you see with time? Replace that probably when
That's a good question. That's a calculation that I want to do at some point, but haven't done. We do have, there is one other high DM FRB that we detected recently that is way more energetic, but for different observing reasons, we haven't been able to secure a host redshift. So potentially stay tuned, but that's a good question.
Okay. Thank you. Do you like to spend 30 seconds?
Yeah, sure.
To ask people to take home
Okay.
message? Give the message. You have 10 seconds already.
Okay.
You have
Uh,
10 seconds.
it made me nervous. Sure. How can I play it? Anyway, so the first 15 minutes, first 15 seconds, I would like to advertise the FRB 9520. So this source is not that high event rate like the other FRB, but the long-term activity is very, very important. So it offers our unique opportunity to take to do the propagation investigation or the scattering or something. The next 50 seconds, I will.
So this session we will leave the discussion. I think today's discussion will focus on fast radio burst population. Or in fact, what we want to focus is, do we need multiple populations or not? In fact, it will relate to different kind of phenomena, like different luminosity distribution and different environment or repeating or non-repeat. So is as our tradition. So the first question will be, do all fast radio bursts repeat? So we can scan this QR code and vote. Oh, sorry. Okay. It looks like in the table, already, so we have more people to go. Sorry. We still need the code. Okay, is every people done? If you have not done, scan this. So let's see the result. Okay. So here is this year's result. We have 60% people think we not all fast radio bursts repeat, and if we go to, let me would like to thank okay, go to PowerPoint. Okay. Yeah. Here is what we have here. Then it is the
So we are in some months. So the question is, why do you change your idea or keep your idea? Okay, so is there anyone who share their the idea why you change your opinions because of the times results? Since they go on the same road, companies and non-Indian companies, or someone who is a fraction of passengers too much, and depends on someone's theoretical prediction. May indicate passengers reaching the place with the most repeat. Or is there any of you just keep your idea by any reason? Is it you have not received any very good video at least for the keep it on?
So about the reflection of the typical time we used to go, and so if we take into account that the inverse connection between how comments and how active they are, this actually automatically leads to the fact that the number of reflection of the video that you observe in over time, the function of time of the reflection sensitivity, very nicely changed to all of them change. So the fact that we have only a few percent, 2%, 3% of the time population that have not seen the video, actually being steady in that sense. So even in that particular where whatever reason seems to be giving 5 billion legs, you will still expect it. So we should be careful by taking that face value. And there is of course the nice work like Jaini and the mana, you're showing that the current limits that we have in individual sources on the activity side is completely consistent with the continuous distribution of activity.
So when you talk about continuous distribution, I will include all the.
Yes, it's just a matter of time.
So that's enough.
At least, yeah, that is one of, okay, I minority is what with yesterday on the week. Of course, new evidence may say otherwise, but until we have strong evidence in the opposite direction, this is my belief.
Looking to people who work that they are strong, non-repeatable, one of you would just say, how you would not who have sort of like absolutely they would just believe or do you have an idea?
It's just a matter of one of individual users and one lifetime. And I think that one of the lifetime very simply one of Yeah, that's the idea that if you see some association and confidence with something that is basically that's good evidence that we do have one of. One thing to keep in mind is that most of these basic sources that together are very well compared to typical climate clouds, especially if the climate clouds are active many times over life. So if we just think of it in terms of what fraction of the population they should protect. Just you can start another leg, you might have and right. And that is because of that is that we activate the beginning time during even if they're low, we'll be able to see even more. So I think a very important that you cannot see a very clear by only using the target between the P and the so I said even if 300 is I guess it's my fault that I'm ready to have to make other therefore my fault would be but if we just see the young people will have value approach. Maybe if you have a whole lot of people that I have to lot good value opportunity all of their so
my feeling is one of not have a complex quality for someone and based on that you love your life. Yeah, I know like this very universally you want to check for things, but you have a lot of people I one of us will take it and the muscles the question looks like you know you don't get it but you have to put the muscles that we are seeing no I think we are I think
Okay, so the next few questions that we have are motivated by the talks that we have had over the last couple of days. So we welcome the speakers and the audience to follow to discuss questions. The first one being the large range in the luminosity that we have seen from different radio conferences. FRB span or propagation luminosity, and the question is whether these are due to the same typical planet producing these for different luminosity due to different emission mechanisms, or whether they are fundamentally different images. You have nanocars, you have the cars, the converter units producing these wide range of luminosity course. The interesting observations that we had today was about the start, for example, when we reported this X-ray electron star that produced right FRB pulse, and it had cyclical EVs as well as and FRB 24/148 has for where it was spanning the 90 cases unity. And it's all the way from the 30% asking by fast to close to 45% approximately by so all of that cars single engine is capable of producing bursts across the turbine capability. We also have the other challenges to these things and competitors. So when we are seeing these concepts, are they produced by single engines, or are they produced by single avatars, or different engines, local or we want to add the points.
So even though I know there's only one type of that they offer heat, in the case of any individual, it depends on the semantics. So first of all, you ask, do all these points have the same mechanism for radio emission? In that case, I would say it's at least equally enough. Right? If you answer the question.
So if you one of the issues is that different emission mechanisms for the nice predictions or what you're going to see in the frequency scale GP. So that would make it challenging for a state emission mechanism to bring it across nice or bring it across the family. But if some of the ways, other ways that are always doing this is the emission mechanism to work.
They do stand, I think what we heard today was a low out the number of the magnitude. I'm going to argue that these 10 orders of magnitude in the known radio posted of Balzan. So given that we know that it is not a different mechanism, it's that have a 10 orders of magnitude that everybody observed and not understood. It means it's not any larger than the range that already observed. It means we are creating a new challenge.
But like I said, we do not understand the mechanisms for those drugs.
That's why I raised the question, Brad. Thinking something was saying, what will it take to understand the emission mechanism of FRB? And I asked, what will it take to understand the emission mechanism of Balzan, which has so much more data, and yet after 50, 60 years, we still don't understand it, and maybe in 60 years, we'll get understand this.
I think the proposal to that even though we can absolute specifics, we haven't even realized by the multi-way population, as well as very complicated modules itself, where they're able to be the kinds of variations you know, compared to radio. It's very, very similar to I think you can bring in the five to now. And if I'm able to replicate some of the motivation of what we see, even producing security radio around maybe predicting the way that so it's not completely solved, but it needs to go away with no. And you have to map technology. I mean, very low in prediction, very small. Now comes to produce. So you will always predict what we are going to produce. So they're taking money and being able to roll it out, or say exactly one thing, we can still roll out various across the world. It's when we can move it on, see when we do it.
So something on the importance of monitoring typical stars. I think so. I think this we not following this on the way of life, because we see not having open degree all of them. And with now when we find FRB now, and then we realize that we're mapping right, and so we use it like more than 9 but I think we radio with staff, but it's decent staff with radio quite concerned that we can fall into the gap where we discovered that we're high energy and we looked at them for a couple of hours, and then didn't see any fault radio emissions of the people watching them. But it seems now especially the radio requirements that will show a lot of emission in front of them, in the part of the electromagnetic spectrum. So we do think that there is definitely increasing in the synthetic compared to the canonical minimum for quality. I would call that normal. Definitely not. I think now evidence is really showing that these technologies will become very interesting. And I think really emphasize this one thing is that we need to continue monitoring these ways. Especially small dishes, because I was told we look for the medical, we can't have to put it like that or other tests, I mean, that's not really good. But there's so many small radios just around the world. And these things are luminous enough that they won't easily detect before. They're out like that, one thing you can for the two so we should just be using these models and continue to monitor them to get I have a feeling that remind us along enough after all this sample and including radio or radio these sources also want to see even over the world and things except that really not that it could be not
yeah, because I agree with that that keep in mind that YouTube stuff doesn't know because they might have out in Balzan, because a lot of people that are working in mind between those applications, but there is a mechanism that is about people who know the YouTube stuff. We also know the example of the locally back now, they try to make them with web, the local build the standard line of the population and make sure microphone action. So as well as we're talking about rates that are very low and the energy system low and very low, this is certainly be part of the bigger picture of the conditions that we plan for this stuff. And to connect back with the radio from million, there is some complication that we still have local bases, regardless of what the situation in the past out. And that is because the energetic system for bases are a lot more higher, and we also think a lot higher. And what we mean is that there are some considerations, today, but also others which apply to the bases don't apply to standard class elimination. And that extremeness of the could actually be a useful, could actually lead to some kind of corner that we push the physics into, there's not much room of wiggling up.
So, I think that's a good score, because the fact that we are seeing that relatively extreme strong alien feature and the non-human population is still completely overshadow and inconsistency mechanism what supplies in the heart of the force. So I think it could be a good spot where yeah, this pushes us towards some parameters, but in other parameters as well, you can the image. The nature of the world perhaps happening and regarding the first one, magic process could also be a translated common, meaning they could be light phenomena or duration of time and so they happen just duration and they were typical. Yeah.
Regularly point out that I want to emphasize another important problem, which is the geometry Guiyang. So we with the GRDs, we also cover the panels and attitudes, and the ratio and so on. So then there are times, we know those things are big, and there are times that are really quite long, the beginning, down to which we want to write it. Think is always and often what is a thinker, and what you are doing is that we see that so right is all of them, and 55 0 now will be converting. And 70 was practical is that we don't know 30 degrees. the geometry must be there, and I'm attempting to also propose a new design model in the FRB scenario, but we take one step back. It looks like for both geometries and AGMs, there must be also intrinsic parameters that sit beside this analysis. There's always a combination of intrinsic factor and the factor. So I would expect that FRBs, we also have those. So in some cases, we have produce more efficient than right-hand FRBs. In some other cases, it's really is quite important because just for the galactic nebula force, it is less bright compared with the more regular FRBs in the universe. But we also have this X-ray counterpart, and if you look at the X-ray side, it's much lighter. There is one piece of evidence that this source have developed much fainter radio bursts and some of them are associated with radio bursts. And one of them was a comparable between NASA as well as the FRB, but many of them is local. So at that one, because it is top axis FRBs, we expect nothing more. The range is longer, so there's closure relationship, and in that case, it seems to be more consistent relation. But I would think that FRB radiation must be much narrower than expectation, and we should consider some kind of leading effect. Even speculation, because we don't have actively either in the meeting. And I have with other galaxies just speculating, maybe some momentum are active leaders. So we just move some other directions, and aliens from other galaxies can see that activity. And we're just not noticing. That's my expectation.
So if we talk about regulars, what is your expected difference between the low university ones?
So these are associated with some sugar reaction, like the earthquakes that start with it. And the amplitude of those earthquakes has to be huge. If we don't have earthquakes, it's not the triggering the start and the Japanese something. But on top of that, we also need
I still haven't seen any evidence that one of FRBs could come from manufacturing layers. I mean, these are very rare events, last almost years ago. So they would look like the ones of FRB. Maybe there are actually several ones of FRBs, so in another way, because we really see really planning for a job there about 4 years. Yeah, because don't talk about last month, 20 years.
I think there was some quite big related to the story that was something that had together 1905, the time that we were looking for the giant there. And there are stringent constraints on the deviation of radio goes into the generator and nothing constant. This is relatively because mentioning we have a lot of this have to do with the being handled of the burst because there's now very large simulation files. So we may have this is the FRB because that's just on the development. There are simulation constraints of people tended to develop. But if we want to add to the question of why it's hard to see, actually compare it if you go on.
Just to clarify, for the diagonal momentum is the one from
Okay, yeah, that's
at the same time, well, the constraints come from observation, that will be very, very far off the whole side. And again, there's also that open, that a lot of land comes between the galaxy, and very easily, they're finding them very unscattered. And so those constraints, you have to, those people constraints on the extreme material from the middle of the yes, but it was found scattered and not to be
yes, there are also we want to be starting the better one would be just the between the Navin simulations of vectors and the pollution that the supposed role of the natural surface is also large for was the very facility
Yeah, the radio observation that end was made by Andrew Line, and it had a 1 second degree circle. So if the scanner time was like 10 seconds, it just completely washed it out and you would see.
Do you expect that to happen within seconds?
Well, the thing is, if the scanner time was like 5 seconds, you can't detect it with that system. So that limit was only true if it was in positive with less than a second duration.
We could was tomorrow. Are we in a push to the first mortality?
it depends on the matter of the law. And where it is on the ground. I have another suggestion to one friend. So if we want to know if that should be associated with the FRB, we don't need to say selected on one galaxy. In the last few videos, we privately include diagonal candidates from nearby galaxies up to say 5 million passes per month. And we detect regulars from that, there's nothing like too much in terms of regular activity. Regular is always easier to detect than the high level. Usually it's the opposite problem, and it's why we have a lot of trouble finding any counterparts based on trying to measure that. But going to this direction, actually looking for those diagonal candidates, seeing if there's already good regular observation, those applications would be quite useful to teach us more systematically any possible demand.
Thank you for the line. The one challenge is that we to distinguish that I said potentially there is some problem. But for when we have
now that knowing something about the almost 10 good candidates, I think a good candidate.
Where are you going to work the one with well
Yes, there's nobody to ask you this, but conversely, we have happening on the X-ray emission of some of the universe that we saw that with this kind of emission of the so we have this kind of association. Of course, it's quickly we're just there with the kind of emission and closing of the universe and also some industry, but basically we could see that such as that one really goes to us in the
Thank you, Mark. Do you have any other questions, comments on these topics? If not, we'll move on to the next one.
Yeah, so we only have limited time. So unfortunately, we cannot discuss every
Almost this is definitely because it's for developments, they found here as sub-option. The main question is, do these systems pose special features different from other non-traveling problems? Or are these just some lucky avatars sitting next to unrelated radio source, for example? the motivation for the questions, we have not seen a lot of PRS candidates from non-dwarf galaxies. So, whether the PRS that we have seen from dwarf could be related to some aging activity or some dying natures, for example. Yes, that's yeah. We have B plus B dollar frequencies, with variability in the flux as opposed to which suggests that they could be potentially same engine. But like I said, the fact that we have not seen them from non-parts sort of bring up the question of whether they could be unrelated, and there have also been other transits like telephones also seen from dwarf galaxies. Could these FRBs with PRSs be somehow related to other transits like telephones, other engines? So that's the question. So are these people sitting next to other radios or are they special engines? Yes.
But still, as a Turkey, Turkey is a little bit of selecting for perhaps very lucky against even our guys. But the statistic is that I think the number is that only 6 magnetons of which radio can be observed. And one of those is within 1 parsec of a the 4 billion black hole. Now, I don't think anybody says that in black hole eject in black hole as well. So, it's quite unlikely because think about it, on galaxy to be that close to a black hole. It is really way overrepresented, but it's not what called it's not a causation. It's really a correlation because it's wrong. And I think the question is, does correlation imply causation one way or the other? There, the odds are probably much lower. Correlation profile, it is pointing that, but even for our galaxy, but the correlation, I think, is much powerful.
And the fact that we have also not seen radios of the magnetron the one that we have is 6 radios magnetron 2. So, are these special particle magnetron or predictions in your class?
I don't know what else why you think it is lucky. So most of these have high RMs. Correlation between the friends when you have the and the RMs. Those that we don't detect are consistent with not having a good RMs. You have a percent RMs pretty high, but
still be the gap. And there are many opportunities, but we are evaluating that motivating the idea that maybe
so equation of we have say FRB with a high and PRS is the last right down so we are wondering whether they have similar results. So if you only
it's so easy, and also that that will be that this is like but today's law, we still have some well, impact on 1 month of the level of well, no, some really
so there's some abstract properties that happen, you know, and but also not on the point. Yeah, so we'll ask you kind of like one of the in terms of last to the well, no, I guess in terms of the velocity of the PRS, the relation that we have right. Well, I think what we can ask is there are 5 PRSs are in the systems where there's a clear correlation between R and the movement of the PRS. So if you extrapolate with PRS source and give it the PRS will not be receiving the PRS source. Yeah, okay, there you go. But we don't see it, so we have a piece of the loss of the R and the PRS. You're like, what's in the okay. Yeah, thank you. No.
For a very long time, I thought maybe there's number of sources, but they're actually they have highlighted, and until they started to empower those, like all of them, most of them were seeing this more gaps that started to be a little bit different. So thinking that if there is younger, then the majority of the transformation rate are still not in those gaps. They are a bit higher, more weighted and based action, but still so we're seeing some numbers in the box, then we should also see more younger sources in the spirals. Yeah, so then we should have that large movement in the spirals. So I started to feel that at least the environment should play some role. In the national arms election, I know, but I'm not really I started to feel that there are special sources and related to you know, how is the role and also the way I was
Someone was
Hi, I'm I did want to mention that we will have a real program for client opportunities where we have a one example. We just really getting cuts on our end, but the analysis of this is still ongoing. I'm really listening to the platform, the guys and I'm going to get on it. But all of them did have significant not sure whether the data has to be good. In terms of the environments, I do, this is also kind of a different for around Thursday, but I do think that there is some environmental protections for the dependency on PRS production. Specifically in that regard, FRBs of the PRS not currently in the so I think that could be a key ingredient to having PRS, but it's not very clear to me whether you need the repeating nature for FRBs to have a PRS. So far, all of the FRBs that we have a PRS number are also active use, but I'm not actually sure that that's really possible. But yeah, just to say that I do the environment.
Very interesting. So it does you have to go and just look at all the galaxies, most of the I thought this is kind of and see whether it's a common feature where your parents is to have some PRS. So what PRS, if that's the case, then now it's going to just by chance and do something else.
Yeah, I actually did look at an example of radio sources in Google Galaxy too, and there was one that was very much like the PRS and we associated with FRBs. We did even have a GPT program to look for FRBs as a position. There was no detection of FRBs, but Marnie has a large program where she's doing a systematic search for compact resources within the galaxies. It's also volume limited, I think, but it's about 2,000 and she's finding these resources. But I think it's kind of hard to say what they are, like the communication, the cell information, the analysis of that is also ongoing. But it would be interesting to search for these acquisitions.
Yeah, you find one there, that These are the overall Furlan today. And she mentioned that she also looking yes, because of the very long I think they're not doing the research and more
So the fact that we see PRS is going to be associated with the technologies, and also PRS flexibility to be coordinated with the birth rate, does mean that like there is a sort of contribution of the like integrated births to the PRS investment. I mean, like the PRS would be like the correlation could be based on the integrated birth census.
Typically, it's known that when you have this to come to the beginning, like that however, the comment of the associated confidence with the topic, the two things that I think is very useful in this topic, the only that we will know one to really put as long as we things as we can in the source side. If the source side is really like 0.1 passing or something like that, that we show where we are able to, that's we have a very confident association. The other thing is to really look for the set of blockchain interval in the PLS. Once we find that, in most PLS models, we expect the PLS to be quite a lot. So we know that frequency, we better not say this. And if we do, then that becomes very interesting. Right? So that there's something else is going on.
There are some GMRT observations before and with others.
Yeah, so we're just like, so we're really trying to see if there's a reduction of the rate.
Yeah. We will.
So basically, O114, very often repeated. These two is the first, starting from low and high. Yeah, right. So I think that probably has been suggested that we will at least some.
So I think it should be going to yeah. So based on some of these questions, different poll these will get on and
Let's see. Okay, okay, so we will go to our. No, that's okay. We'll just use it.
let's go to this pool to to guess how many sentences do our fast radio bus have. And please scan this QR code.
Certain more things for how many different kinds of agents do you think are producing? Different agents could be neutron stars, black holes. Maybe non-standard black holes isolated non-stars and non-stars. Why not use these can be different? Yeah. Okay, we'll close the poll in the next 10 seconds and let's see.
So are you done?
Wow.
Okay.
So we really want someone who has an answer in 26 to the class. Someone brave enough, please. Is someone brave enough to explain their number 6? No, okay. That's probably a true answer. Yes, that. Yeah, that's like there's lots of different ways to produce organization. And maybe whatever we see about it's like the more we look at it, the more. Okay, so the line explanations that will be different emissions mechanisms operating in different kinds of engines, binaries, and so on. So whatever. Okay, now that's YouTube now. Okay, so we would want
only one sentence, so that's,
yeah.
and in any model, inside, doesn't put it on, or, but that's what we do, oh, I'm going to start with.
What monitor do we want? Yes. Why do you think this is one population approach?
Well, I mean, first of all, I think if any Bayesian analysis, you have to pick a number, I could have, let's say every day every year there are 10% of these going off, maybe there are 10 different mechanisms. So if everyone keep a chance, expectation of mechanisms could be as many as FRB that could be observed. Therefore, we start with compensator and say what the fewest that have not been pulled out yet, that surely have to be designed for otherwise, in the active, if we have a gas of bigger than 10 million, like that, that we can go of them and how that's really by compensator observed. And even though chance that we go 10 million and 10 million one, we need to chance, and that's why you like we don't think. So that's why I think one has to be taken and you have positives and turn good out. And now we look for what will it take. The better question is, what will it take? That is on the bar, something like that.
What would it take to prove it's more than one? And that was also the main question we had in our last slide. what kind of instrumentation facilities, what kind of analysis procedure or here for the to conclusively show that there is one other, at least two more, one less population or region for what do we need to conclusively show? You all, most of you all just agree that there are not of these, yeah.
I think what we're really out there is finding stars and positions of FRBs. They're like individual stars that are moving this direction because we get more nearby outsiders, we get better localizations, and we get better local points. Within a few years, we can say there's a couple or at least one of those stars which should be FRB, and the other will be individuals that are completely in the local region.
Essentially, finding the finality, so anything else that you want to add to this? What other developments do you want to leave in terms of this will be this analysis?
I wanted to come back to the point about how we normally look at FRBs. And I think we should really utilize all kinds of improvement. So for example, there's a lot of most have actually black and it's going to be really hard to draw into that position for parties. So for if we have like say a bank card that comes from four classes with another for example with the bigger together, then finding a also counterpart that the classes with another would be a very strong evidence.
Ruben, very in terms of this motive, I got a really big outside because we have more the last side. If you do not have enough time to monitor that can help you answer if your FRB. And I still remember there's a paper published China. We use China title, if you use the same thing. That is a kind of communication. You better to make a money if the cost guy to answer this question. Ideas? Yeah, I think we are requesting time. Thank you all so much for participating in the discussion. That's all the topics. This is very new, yes.
First, before you leave, quick announcement. So most of you told us you will spend you also know that the last the matches with things. So some of you haven't noticed. So please send us a message. Your email us. You haven't told us that you need to say what happens with this. Because we need to arrange the bus. You need to tell us how many buses you need to do. So we'll support you. So if you haven't done so, please do let us know by the time. Thank you. Okay. Yeah. Have a good day.